Okay, the next two sections I'm going to take together are based on previous algebraic knowledge. So these are heavily dependent upon a good working knowledge of chapter 1, 2 and 3 of the first book. And the first one is the relationship between a point and a circle. And when I talk about the relationship between a point and a circle, what I mean is the comparison of the distance of a given point from the center of a circle in relation to the length of its radius. Now I'll deal with more about that in a few moments. And secondly then, the relationship between a line and a circle. And I'm going to take both of those sections together here, so there will be a fairly substantial chunk of work left at the end of this chapter for you to get through questions wise. But again, if you run into difficulties, you can email me and I'll help you out as best I possibly can. So let's take the first of the two relationships, the point and the circle. Now, there are three relationships, okay? Three possibilities, and this will show it to you here. If you take the circle, which we will call X, let's call that circle X, okay? Circle X has center HK, because don't forget, we don't know where it is, so we call it HK. We're not too sure if it's 0, 0 or not, so call it HK. And it has point on the circumference called E. Now, the relationship obviously then, let me just move that HK out of the way. The relationship then between between E and HK, or put another way, the center and E, is that the distance between two of them will be exactly the same as the radius. Okay? If, for example, point D is inside the circle, then the distance between those two will be less than the radius. And finally, if you have a point C, well then the distance between the center and C will be greater than the radius. And they are the three things we have to look for when we're doing questions in relation to the relationship between a point and a circle. Now, I'm dealing with what we call the algebraic relationship, okay? So if I give you a point and I ask you what is its relationship to the circle, there's really only three things. If the distance between the point and the center is less than the radius, the point is inside the circle. Okay, and when I talk about inside, I mean inside the circumference. If the distance between the center and the point is equal to the radius, then obviously the point has to be on the circumference. And if the distance between the point given in the center of the circle is greater than the radius, well then the point must be outside the circle somewhere, way outside the circumference, on a different, longer line than the radius would be itself. Okay, so let's take a look. C is outside, as we already know, D is inside, and E is on. What does that mean? It means that the distance between the center and C is larger than the radius. If D is inside, the distance between D and the center is smaller than the radius, and if E is on the circle, then the distance between it and the center of the circle is equal to the radius. So how do we work these out mathematically? Let's take a look. In order to reveal the relationship between a point and a line, simply substitute the point into the equation of the line for x and for y. Because every point, don't forget, has a numerical x and a numerical y. So if every point has a numerical x and y, and you want to see what the relationship is between that point and a circle, you take the numbers of x and y in the point and you bring them into the equation of the circle. And if the answer on the left-hand side of the equation comes out to be smaller than the right-hand side, then it's inside the circle. If the answer on the left-hand side of the equation comes out to be the same as what's on the right-hand side, then the point is on the circumference. And if the answer on the left-hand side comes out to be bigger than the number on the right-hand side, then the point is outside the circumference of the circle. So what I'm talking about here is the equation. You have a left-hand side and you have a right-hand side, okay? And there are three things can happen. The left-hand side can be equal to the right-hand side. That's an on relationship. The left-hand side could be greater than the right-hand side. That is an outside relationship. Or the left-hand side of the equation might be smaller than the right-hand side, which means it is inside the circle. Okay, so we're going to do this algebraically to show you there's no better way to learn these things than to see these examples done properly. So here's an example. Investigate. Is the point 5, 4 inside, outside, or on the circle? In other words, when I take 5 and 4 as the values of x and y, and I put them in there, 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 and there, how does the left-hand side of this equation compare to the right-hand side? Well, let's do it and find out. 5 squared is 25. 4 squared is 16. 2 5s are 10. Minus 6 4s are 20 minus 24. Minus 15 equals 0. Let's see what that works out to be. Now 25 and 16. plus 10 minus 24 minus 15 is equal to 12. So we end up with a nonsensical statement that says, oh, 12 equals 0. No, it doesn't. 12 is greater than 0. The left-hand side is greater than the right-hand side. So there, this is an outside relationship. So that 5, 4 is outside the circle. Why? Because when you put 5, 4 into the equation, the left-hand side of the equation comes out as being larger than the right-hand side. And if that's the case, then that means that the point is outside, or the point is further away from the center than the length of the radius. Okay, so therefore, there it is in typed out format for you. So you sub in 5, 4, and then you get 12 equals 0, which is false. 12 is greater than 0, so the point is outside the circle. Okay, here's another one. Now we're going to start bringing a little bit of algebra in here. Find the value of k, element r, so k can be any number, positive or negative, such that minus 2, 1 lies on the circle. Now, what does that mean? Well, first of all, if that point is on the circle, then the left-hand side of the equation will be equal to the right-hand side. Okay, both sides of the equation will be the same if the point is on the circumference. So all I've got to do now is put that in here into the left-hand side and set it equal to 0. So minus 2 squared is 4, 1 squared is 1, 3 times minus 2 is minus 6, minus k times 1 is minus k, plus 5 equals 0. And it must be set equal to 0 because we're told the point is on the circle. Tidy up the left-hand side. 4 and 1 is 5. 5 and 5 is 10, minus 6 is 4, minus k is equal to 0. Bring the minus k over the other side, 4 equals k. Done. Simple as that. That's it. Okay, and again, I have that printed out for you so you can follow it step by step. You put it in, you get an equation that gives you minus k equals minus 4, so k is equal to 4. Okay, what about this example here? A little bit more algebra this time, but look at the words that are in this question. Find the range of values. Now, there's only one type of equations that we've studied in algebra that can give you a range of values, and they're inequalities, okay? Every other equation that is an equality will give you one answer if it's linear, 2 answers if it's quadratic, 3 answers if it is a cubic equation. But if you're looking for a range of values, that means you're looking for a whole group of values that can satisfy this particular equation, this particular statement. The statement, therefore, must be an inequality. All right. So that's a little bit of a hint that we're going to be dealing with a less than or an equal than sign. So that's an inequality. Okay. There's a bit of a hint there. Such that the point 5t lies inside the circle. Now, if a point lies inside the circle, what does that mean? It means that the left-hand side of the equation is smaller than the right hand side. So meaning when I take 5t and I put 5t in here, that will come out to be less than 29. Okay, because when the left hand side is smaller than the right hand side, it means the point is inside the circle, and that's what we're told it is. So let's put this in. 5 minus 3 is 2, 2 squared is 4, plus t plus 2 to be squared, leave it, we'll look at it in the next step, is less than 29. So now you have an inequality. So you end up getting 4 plus, this is a binomial, you can square the binomial quite easy, it's t squared plus 4t plus 4 less than 29. Now 4 and 4 is 8, so t squared plus 4t plus 8 minus 29 is minus 21 less than 0. And the reason why it has to be less than 0 on the right hand side is because when you're dealing with a quadratic, quadratics must always be set equal to 0 in order to solve them. So now hopefully we have a nice little quadratic that we can solve. T squared is t by t. Factors of 21 with a difference of 4 between them are 7 and 3. However, I want the difference to be plus 4, so it must be plus 7 minus 3, meaning t is equal to minus 7 or t is equal to 3. So they are my two bookends. Because it is an inequality, they immediately go onto a number line. Now don't forget that. They have to go onto a number line. Okay, so when you're dealing with an inequality, you always solve an inequality by bringing these bookend values, these solutions to the quadratic, onto the number line. So there's minus 7 and there's 3. Now, what does that mean? That means that my answers, my range of values, are going to be between -7 and 3 or outside -7 and 3. And the only way that I can find out where the range of values are is by testing a given value from the number line that is either between -7 and 3 or outside -7 and 3. Now, the easiest value always to choose, if it's available, is 0. Now, what I mean by if it's available, that means that it's not one of the bookends themselves. It's not one of the values that you have as a solution. All right. So if it's available, which it is, we then take that back to the inequality in t and we plug it in for t. And that's going to give me 0 plus 0 minus 21 is less than 0, which is true. Which means you cannot use -7, you cannot use 3, but you can use every value between the two. Which means that t will be between -7 and 3, and you use the same symbol that was in your inequality up there, and that is the range of values for t element r. That's your range of values. That's it. So between -7 and 3 exclusively. So it can't be -7, it can't be 3, but it can be every real number between the two. Okay, so again, I have that done out for you. So let me take off my own handwriting there and bring that up for you so you can have a look at that yourselves. And if needs be, you can pause it if you want to see each step on the way. But it gives you, as we said already, -21 less than 0 is true. Now, what does that mean? Well, there's your 3 and your -7. So you put these on the number line. That's what I meant there. -7 and 3. So you test 0 back in the inequality, which means you bring it all the way back to here. And that's going to give me that -21, which is true. So I can't include -7, whoops, and I can't include 3, but I can include everything between it, which gives me, as we said already, not that, that's rubbish, don't worry about that, it's a misprint of my mistake. That means t is between -7 and 3, like that, x, or t, in this case, t element r. Okay, so don't worry about that, that's garbage. I printed it out wrong, I'll change it on the slides. Okay, let's take another one. Now, let's move up. We've done points and we've done circles. A point can be on a circle. What does that mean? When you put the point into the circle, the left-hand side will be the same as the right-hand side of the equation. The point might be outside the circle. So if you take the point and put it into the equation of the circle, the left-hand side will be greater than the right-hand side. Or the point might be inside, which means if you take the point and put it into the equation, the left-hand side will be smaller than the right-hand side. So they are three things you have to remember. One is an equality or an equation. The other two are inequalities, which will give rise to a range of values. All goes back to the first 3 chapters of book 1. So let's take it a step upwards. If there are 3 relationships between points and circles, there's going to be 3 relationships between lines and circles. And here they are. And again, graphically, let's take a look at the possibilities. We've got 3 possibilities here. 2 of these diagrams show a relationship between a line and a circle. One of them shows no relationship between a line and a circle. Now, it's easy to see that both of these have a relationship. And they have an algebraic relationship between them. This one here, there is no relationship. And the very reason why there's no relationship is because there's no intersection. These two don't agree on a common point or common points. All right. So there is no relationship there, which means there is no algebraic relationship. Now, you'll understand in a moment when I'm talking about an algebraic relationship. Okay. These two here do have a relationship. Okay. However, this one is what we call a tangential relationship. And this one is a non-tangential relationship. Now, what does that mean? If it's a tangential relationship, there is one point of contact between the circle and the line, which means there is one algebraic solution. Okay, just keep that in mind. There is one algebraic solution. If there is a relationship, but it's not a tangent, then there will be 2 algebraic relationships. Solutions, I should say. So there'll be 2 algebraic solutions. Okay, so if there is no relationship between a line and a circle, then algebraically speaking, no solutions to the garbage that they're going to bring. Okay, if there is a tangential relationship between a line and a circle, then algebraically speaking, there will be one solution to their algebraic relationship. And secondly, if there's a relationship that is non-tangential, then there will be two solutions to the algebraic relationship that exists between the point and the line. Now, how does that work? And again, let's go back to taking a look at some examples, because it's much easier for me to give you examples than it is for me to talk about this thing. So, as we see down there at the bottom, let me just take off some of that print there. Eraser. There we are. Ah, it's not working. Take off all the text. Come on, take off all the text. Oh, okay, we'll go on to the next slide in a minute. Anyway, when they intersect and have points in common, we will use simultaneous equations. So that's extremely important. Simultaneous equations will always be used to reveal whether there is a relationship between the circle and the line, whether there is no relationship between the circle and the line. And if there is a relationship, is it a uni-solution relationship, meaning a tangential relationship? Or does it have two solutions, meaning it's a relationship, but the line and circle are not tangential to one another? And that's what we want to look at here. Let me just check that again. All the ink on the slide? No, not letting me do anything. Apologies. No? Okay, let's move on to the next one. Now, if a line and a circle do not intersect, the resulting quadratic will have no solutions. What does that mean? We'll just go back here to the previous slide for a moment. And my technology is really letting me down big time. It's not letting me do anything. Apologies for that now. Ah, here we go. Good. So when they intersect, they have points in common. Therefore, we will use simultaneous equations. Now, you'll use the simultaneous equations to build a quadratic equation. And if the quadratic equation has no solutions, then you're dealing with this scenario. If the quadratic equation has one solution, you're dealing with a tangential relationship. And if the quadratic equation has two solutions, you're dealing with a relationship that is non-tangential, but very, very present. Okay, so keep in mind, what are we going to do? We're going to take the line and the circle, we're going to push them together into one quadratic equation, and we're going to solve the quadratic equation. Okay, so I'm going to give you three examples, and I'm going to work through with you. I'm going to take each one separately, but I want you to watch the wording. Look at the first one here. Show that the line x plus y does not intersect. So therefore, no relationship, meaning no solution. There'll be no algebraic solution. So you're going to try and push these two together, the line and the circle, into one quadratic equation that simply cannot be solved. Okay. Next one. Show that the line L, 12x plus 5y equals 169, is a tangent to the circle C, x squared plus y squared equals 169. Now in that situation, again, we're going to try and push the line and the circle together into one quadratic equation. And when we solve that quadratic equation, because the circle and the line is a tangent to the circle, that means there'll be one solution. Okay. And lastly, then we're asked, does this intersection between that line L and this circle here, C, does it involve a tangential relationship or a non-tangential relationship? So we are told that they do intersect, but we're asked to figure out, is it a tangent or is it not a tangent? And what I mean by that is, when you take L and C and push them together into one quadratic equation, does that quadratic equation have one solution or does it have two? Because based on the number of solutions, we will then know whether it's a tangent or whether it's a non-tangent. Okay, going through, as we would call it forms a chord between 2 points, or it gives you what we would say, what was the word we used the last time in the question? It was not a sector, secant. It was a secant. Go back to the very first slide, you'll see a secant. Okay, so a secant is a line that runs through 2 points of a circle and the circumference of a circle, but not through the center. Okay, so let's take the first one. Show that the line x plus y equals 5 does not intersect the circle. Now in that situation, if it does not intersect, then L and C have no solution when you push them together. But the question is, how do I bring them together? And the answer is you solve them simultaneously. Meaning, you put the circle equation and the line equation together. X squared plus y squared equals 5. And then the line x plus y equals 5. That should be 2 up there, shouldn't it? Yeah, 2. So, apologies now. So, the circle is x squared plus y squared equals 2. And the line is x plus y equals 5. Now, again, this brings you back to the beginning of book number 1, the first 3 chapters. In there, we dealt with simultaneous equations between a linear and a quadratic. And if you remember, the steps behind that, the very first thing we did was we always rearranged the linear equation. So in this case, if I rearrange that, I'm going to get x equals 5 minus y, which means I have discovered what x is. Now, I haven't discovered x numerically, but I have discovered x in terms of y, which means that I can now bring this new representation of x up into the quadratic equation, replace x with 5 minus y, which will give me a quadratic equation in y only, meaning it can then be solved. Okay, because don't forget, when you're dealing with algebra, equations that can be solved are equations that are only written in terms of one variable. So what we're trying to do here is we write x in terms of y, and then we take the new version of x, which is 5 minus y, up into the quadratic where x is, and rewrite it as the following. 5 minus y to be squared plus y squared equals 2. Again, a binomial expansion gives you 25 minus 10y plus y squared equals 2. And when you tidy this up, you get 2y squared, that's those two taken care of, minus 10y plus 25 minus 2 is plus 23 is equal to 0. Okay, now that quadratic there should have no solution because they don't intersect. So this is what will tell me now whether the question, or whether it reveals there'll be no solution or whether there will be a solution. And the quickest way to solve any quadratic, if you want to, is go to what we call the quadratic formula. Okay, and what we're expecting here is that the quadratic formula will tell me, sorry, I can't be solved. So let's try that. A is going to be 2, B is minus 10, and C is 23. So minus, you know the formula, minus B plus or minus the square root of B squared minus 4AC all over 2A. Let's bring it up here. So minus B becomes 10 plus or minus the square root of 10 squared minus 4 times A times C all over 2 times A. So I get 10 plus or minus the square root of. Now watch what happens under the square root sign. 10 squares is 100. 4 twos are 8. That's 24. 8 to 16, 18. Minus 184 all over 4, which becomes 10 plus or minus the square root of minus 84 over 4. Notice anything? Minus 84 square root, no solution. And if there's no solution, no intersection. And what did the question say? Show that there's no intersection. We have just shown that by the fact that we end up getting a quadratic that cannot be solved in real terms. Now, it can be solved using complex numbers, but we're not getting into that now. It's not solved in real terms. Okay, next one. Show that the line L, 12x plus 5y equals 169, is a tangent to the circle x squared plus y squared equals 169. Now, is a tangent to, meaning when you push these two together and you solve the quadratic equation that results, there will be one solution for x and y. Okay, meaning that there's only one point of contact, meaning that the line is a tangent to the circle. So let's take that. The circle is x squared plus y squared equals 169. The line is 12x plus 5y equals 169. Now, they both end in the same number. That's completely coincidental. Doesn't mean anything. So don't get carried away thinking, oh, they're both equal to 169. That means it's going to be a tangent every time the two equations end up. No. All right, don't take it like that. So what we've got to do is rearrange the linear. Here's what I'm going to do. 12x is equal to 169 minus 5y. That gives me x equals 169 over 12 minus 5 over 12y. Fractions, they do exist, they do happen. When they come into a situation like that, use them until you can safely get rid of them. That's the key thing I want to tell you about here. So there's x. So that's my new representation for x. So now I'm going to take that back to the quadratic equation, and everywhere there is an x, I'm going to replace it with 169 over 12 minus 5 over 12y. Now bear with me, because this is really where you have to keep your head focused on the question. So what does it become? take out the x squared. It becomes 169 over 12 minus 5 over 12y 2b squared, that's there, plus y squared equals 169. Okay, well, let's square this out. Now, you're dealing with a binomial expansion again. So you square the first one. 169 squared is 28,000. And don't worry about the big numbers. 28,561. Don't worry about the big numbers. You're all big boys and girls. You can deal with big numbers. Just keep your focus on the question. Keep your concentration. Over 12 squared, 144. Okay, plus, because don't forget, we're going to be multiplying, or it's minus, isn't it? Sorry, minus, because we're going to be multiplying those two together. So it's minus. Now, 169 times 5 is 845. Multiplied by 2 is 1690 over 144y. So don't forget, when you're doing this, you multiply these two together, then double the result for the middle term, and then plus 25 over 144 y squared. So that's the binomial expansion there. Then plus y squared equals 169. Now, because there's no brackets left, now it's safe to multiply across by 144. So let's do that. That'll give me 28,000. I'm going to multiply across by 144. Okay, so that'll give me 28,561 minus 1,690y plus 25y squared, and so that's 25y squared, and 144y squared is equal to 169 times 144, which comes out as 24,336. Now, big numbers, but as I told you before, keep your head about you. Let's put the y squareds together. 25y squared, 144y squared is 169y squared. Okay, then we have minus 1690y, and lastly, we've got 28,561 minus, so bring that over here, minus the 24,336, and we get 4 plus 4225 is equal to 0. And it's very important to remember that you've pushed the circle and the line together now using simultaneous equations. You have got your quadratic equation, and in order to solve your quadratic equation, all quadratic equations must be set equal to 0. Okay, so you bring anything on the right hand side over to the left hand side. Now, let's see, can we simplify this? Are these terms here all divisible by 169? I hope they are. Is 4225 divisible by 169? And the answer is yes, 25 times. So now I'm going to divide across by 169. So I'm simplifying. Y squared minus 10y plus 25 is equal to 0. Much easier to solve. So let's solve this. Y squared is y by y. Factors of 25 that adds to minus 10 is minus 5 and minus 5, because minus 5 times minus 5 is 25, and minus 5 is minus 10, meaning y equals 5 is one solution for y. Now, how do I get x? Well, go all the way back up here, because up here you've got an equation tells you to find x. See that? X equals. So it's going to be 169 over 12, so turn on your fraction. 169 over 12. Then minus, now it's y becomes 5, so 5 5s, that's 25 over 12. And when you put that in, lovely, that comes out as being 12. So x equals 12. So there's your x and there's your y, meaning the point of intersection is equal to 12, 5. And because there's only one point of intersection, it's a tangent. And that's what it said. Show that the line is a tangent. And if the line is a tangent, then it simply touches, that's the top of the circle, touches the circle once only, at that point, 12, 5. Okay, so finally then, the last example I want to do with you is this word. And we don't hear very much about this anymore, but it's called a locus. Okay, now, a locus is a pathway whose points are all equidistant from a single point. Now listen to that again. A locus is a pathway whose points are all equidistant from another point. And the only shape we have in our course that satisfies that is a circle. Think about it. If I draw a circle like this, okay? If I draw a circle and I put a point at the center, isn't every point around that circumference the same distance away from the center, no matter what point I pick. Yeah, like spokes of a wheel. They're all exactly the same distance away, which means every point in the circumference has the same distance from the center. So therefore the circumference of a circle is a locus, and the only locus on your course is a circumference. So just remember that, okay? But as a locus is a pathway whose points are all equidistant from another point. And the only shape you have to worry about when we're dealing about a locus is a circle. So if you ever hear mention of the word locus, you know they're talking about not a green thing with wings that flies and eats the crops, but something that is a pathway that is equidistant from a given point. Okay, keep that in mind. Now, where would that come in? Well, it might come in something like this. A circle is also called a locus, as every point in its circumference is equidistant from the center. We know that, okay? But a locus is a path. Keep that in mind. Traced out by a moving point, satisfying certain given conditions. Now, as far as we are concerned, if we are asked to show that the locus of a point is a circle, you have to develop the equation of the circle. That's all you've got to remember. So if somebody said to you, show that the locus of this point is a circle, yeah, then you have to develop the equation of a circle. And it's quite easily done. Let's take this example here. A is minus 3, 1, and B is 0, minus 5, and they are 2 points. A point P, X, Y moves so that so that the distance between A and P is equal to half the distance between B and P. Now, remember the distance formula? The distance formula is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. Now, why do I write that down? Because the distance formula is always used every time you see those two straight lines. Listen to what it says. So that the distance between A and P is equal to half the distance of B and P. So therefore I've got 3 points here. I've got A, which is the point minus 3, 1. I've got P, which is the point XY. And I've got B, which is the point 0, minus 5. And all I want to do is I want to use the distance formula here between A and P. And I want to use the distance formula here between B and P. Use the X and use the Y as they're given. So we have the formula up here. Let's apply it first of all to A and to P. So x2 minus x1, that becomes x minus minus 3, which becomes x plus 3 to be squared, plus y2 minus y1, which becomes y minus 1 to be squared. And that's equal to half of the distance between BP. So let's take these two. First one, x2 minus x1 becomes just minus x to be squared, plus y2 minus y1, which is minus 5 minus y to be squared. Okay, now my advice at this stage would be square everything. Square everything. Get rid of the square root signs. So square the left hand side, you get x plus 3 to be squared, plus y minus 1 to be squared. Now square the other side. It's a quarter of what? Of x to be squared plus minus 5 minus y to be squared, because now the square root signs are gone. Okay, so let's get rid of this fraction by multiplying everything across by 4. So you'll end up with 4 times x plus 3 to be squared plus 4 times y minus 1 to be squared is equal to x squared plus minus 5 minus y to be squared. And all you've got to do now is do your algebra. 4 times, let's square out this binomial, x squared plus 6x plus 9. Here, 4 times y squared minus 2y plus 1. And that's equal to x squared plus 25. And then you have plus 5, that's plus 10y plus y squared. That's it. Okay, now gather your terms together. So 4x squared plus 24x plus 36 plus 4y squared minus 8y plus 4 is equal to x squared plus 25 plus 10y plus y squared. Wow. Okay, now see if it gathers up into the equation of a circle. 4x squared minus x squared is 3x squared. Okay, y squareds are next. 4y squared minus y squared is 3y squared. Next are the y's, the x's. 24x, and that's it, so plus 24x. Y's are next. Minus 8y, minus 10y is minus 18y. And lastly then your numbers, 36 and 4 is 40, and 40 minus 25 is 15, is equal to 0. And the lovely thing you'll notice about that final equation is that everything can be divided by 3 to give x squared plus y squared plus 8x minus 6y plus 5 is equal to 0. And if you look at that carefully, doesn't that follow the expanded form of the equation of a circle? X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. It does. That gives me the equation of a circle, which means that, as it says up here, show that the locus of P is a circle. In other words, show that when you apply the distance formula to AP and the distance formula to half BP, that the equation, when you shove all the algebra together, comes out to be the equation of a circle. Now look at the last part. What's the centre and what's the radius? Now remember what I told you. If it's the long expanded form, then you halve the coefficient of x and change its sign, so that's minus 4. Half the coefficient of y and change its sign, 3, so that's the centre. And then the radius is g squared plus f squared minus c. So that becomes 16 plus 9 minus 5. 16 and 9 is 25 minus 5 is root 20. And just leave it as root 20. So the centre is minus 4, 3, and the radius is root 20. Purely based on algebra, again purely based on coordinate geometry of the line, but I'm going to leave you now with a good bit of work to do on all of those points, which are here, working on pages 302 to 307. And again, if you're doing these and you run into trouble, don't leave it to the live class. Send me an email, get back to me, and I'll send you on the solutions.